So here today, we just talk very generically like about regression. Okay? I don't want to go into too much technical details for today. Just an introduction to regression. So this is if you are going to be a quant, this is going to be a huge part of your work, predicting returns of a stock or a security, and you'll be doing time series or regression or some kind of a machine learning driven value prediction, right? So this is what a quant will do, is to do some way to predict the value. And regression is the simplest way to predict the value. So if I tell you these are the returns of ICICI and Bank Nifty, right? ICICI is a big private bank in India, right? It's not a public sector bank. It's not a PSU bank. And Bank Nifty has all the banks listed in India pretty much, right? So including ICICI. So I've given the returns for Bank Nifty, which is the index of banks, and ICICI, which is a constituent of the Bank Nifty index. Now, which one is, if you know which one, can you predict the other value? So if I know ICICI return, can I predict Bank Nifty for 2025? Or if I know Bank Nifty's return for 2025, can I predict ICICI? Which variable is going to be your dependent variable? Which is going to be your independent variable? In other words, Bank Nifty is dependent, you're saying. So if I know ICICI return, I can predict Bank Nifty returns. So if I know Bank Nifty, then ICICI I can predict. So that means ICICI is dependent on Bank Nifty. That's what you guys are saying. Everyone's saying that. You are saying different, I think. You are saying if I know ICICI return, I can predict Bank Nifty. So Bank Nifty has many banks in the index, right? So only ICICI is only one security in the index. So usually, if you know the market performance or the sector performance, you can then predict the individual stock. So if I know what Nifty is going to do, then I can predict what is going to happen with Tata Motors or Tata Steel, right? So same thing, if I know Bank Nifty's return, then I can predict ICICI returns for next year. To do this prediction, we are going to run what is called as a regression equation. So this is very simple. You are going to try to find the historical line of best fit, right? So historical returns of Nifty, Bank Nifty and ICICI, you plot it in a scatter plotter, right? If we just plot these values, we are going to get a scatter plotter, right? And X and Y axis, you said this is my dependent variable. Usually your dependent variable is your Y and your independent is your X variable. I mean, again, as I said, in level 1, we are only having one independent variable. In reality, you will have many independent variables, which we will cover in level 2. Now, if you do this scatter plot, let's actually do this one. I think we can quickly do a scatter plot. Let me just take down these values as a picture at least. Now let's go to Excel. So we were given Nifty and ICICI, right? We were given Bank Nifty and we were given ICICI. So Bank Nifty returns were 10, 3, 20, 15, and 12. And ICICI returns were 7, 1, 18, 17, and 11. So let's just do a simple scatter plot. Let's see how they look. So I have ICICI returns plotted with the Bank Nifty as x-axis. Do you think there's a relationship between the x-axis and y-axis? So as x increases, is y value also increasing? No, somewhat. Yeah, I think so, right? Like, so if you have just look at this one. If I have like some 3% or so here, I'm having 1% there. But if I increase my Bank Nifty, my ICICI return is also going up. There seems to be some relationship, right? So this is just a simple scatter plot. Visually, you're trying to look at this. Now, I can draw a line, maybe something across this scatter plot. Maybe we draw a line. If I draw a line such a way that I minimize the distance between the observation and the line, that is called as the line of best fit. Right? You understand this? So let's just draw a line across the scatter plot. And we're trying to minimize the distance between the observation and this line. So this is going to this line. If I extend it for any other value of x, I can predict y value. So if I predict ICICI, if I was given some other value of Bank Nifty, if I expect Bank Nifty to do 25%, I can just extend that line and plot and intersect with the y-axis, right? So this is the simple concept of regression. This is all we are doing with regression. Now, let's actually do the regression and see the output. Okay, I'm going to delete this one, but you understand what we are doing from a regression standpoint, right? Now, let's go to regression. So go to your data, and we will go to our data analysis. And we will just do a simple regression, no complicated stuff. Just go to regression. I want my y values is what? ICICI we said is the dependent variable. That's my y values. And my x is the Bank Nifty, the independent. That's what you all said. I do have labels in my data, so I'm going to check that. My confidence level, let's go with what? 95%. Okay, so my significance is 5%. Output, do I want in a new worksheet? No, I want it here. So maybe we will click there, somewhere there. We will also have residuals. You will see what residuals are. Residuals are like the error terms. We will also plot it. We don't need anything else. So like click OK, and that's your regression output, right? So now let's see what the regression output tells us. So this is our basic regression output. Like when you do a regression analysis in Excel or Python, this is what you typically get. And this is how we will predict the future values of the dependent variable using the independent variable. The first thing to look at is the line equation, right? Like you must have studied in your school. It depends on how you studied. You might have studied something like this, mx plus c or ax plus b. What we are going to be doing here, I think the curriculum uses alpha plus beta. Anyway, so we are going to use some kind of a value. So let's use a plus b. I'm not very sure if this is the same notation in the curriculum. So a is your constant, like that's called as the intercept value in a line equation. And b is what? B is giving you the slope of the line equation, right? So in your output for the regression, they have given the coefficients for Bank Nifty. Bank Nifty is what? The x variable. So coefficient of Bank Nifty is 1.08. So that is your slope, right? Slope or B in our, so it is 1.088. Okay. And my intercept value is minus 2.26. Intercept is like this. If my x is 0, what is the y value? That is your intercept. That is where the line intersects with y when x is 0, right? So that is minus 2.26. Basically, we are saying ICICI will be giving minus 2.26 if Bank Nifty return is 0. If x is 0, what is the y value? That is your intercept, where the line intersects with your y-axis. So for me to calculate the ICICI return, it is going to be equal to my slope multiplied by the value of Bank Nifty I'm predicting for next year, plus the intercept value. Now I can predict something for next year. If I say it is 10%, my ICICI value is 8.6. If I predict Bank Nifty 30%, my ICICI return is 30.3. As simple as that, right? You just have the regression equation, then you give a value for the independent variable, then you can get the answer for your dependent variable, right? Understand this? So that's the return. How I calculated this return? Sure. Okay. So this return is what? ICICI return is your y variable, and y is given as a plus bx, a linear equation. And I mean, again, this notation, some people use b plus ax, a plus bx. It doesn't matter. It's intercept plus slope into the independent variable. And the independent variable return is something we will assume for the next year, x value. So if it is some 30%, what is going to be the y value? So how do we calculate that? So that is equal to my intercept, right? A plus my slope multiplied by the forecasted independent variable, which is Bank Nifty return value. That is the equation. So intercept is minus 2.26 plus the slope multiplied by the X value. That is giving you the ICICI return, which is your Y variable. Make sense? So now this is how you do it in Excel. Obviously, in exam, we only have what? Calculator. So we are going to use the same values for our Bank Nifty and ICICI and do this in the calculator. Okay. So I will show you how to do this. I think we have kind of done this already, but we will do this in the calculator. Let's go to our calculator now. Regression is a lot more practical, and I think is relatively easy compared to your chapters 8 and 9. Again, see this notation keeps changing. So I think sometimes they use for intercept beta naught and slope as beta 1. We also see some places the notation as alpha plus beta x, where alpha is your intercept, beta is your slope plus an error term, right? Or noise term. This is your linear regression, univariate linear regression equation. Whatever is the coefficient of x, that's your slope. Okay. Now let's go to our calculator and compute the same thing we did in the Excel. So we have to first enter this in our data sheet. So second data, second clear work. My first value for Bank Nifty X is 10%. Enter down arrow, Y is 7. You can just observe it and I will give you another set of data to do by yourself. You just follow along on how we do it. Enter down arrow, second variable, X value is 3%. Second observation, Y observation is 1. Enter third observation, 20. Enter, okay, 18. Enter fourth one is 15. 17. Fifth one is 12. And 11. All right. So we enter the 5 observations for X and Y in the data sheet. That's the basic thing we have to do. Enter, input the values, then go to your stat function, go to your linear regression mode. If you are in one variable or something else, you might be in one variable, then you shift to linear mode. Then press down arrow, number of observation, blah, blah, blah. We don't need all that stuff. Come to your A. A is your intercept, minus 2.26, which is what we got in Excel as well. And your slope is 1.08. So you have A plus B multiplied by the X value that will give you the dependent variables value 1. Very simple. So whatever we did in Excel, we get the same value here. So just to double check how the calculator works. Now I want you to try this. I know it's simple, but I want you to calculate for another set of observations. So let me give you a slightly different input. So I'm giving you Tata Steel and Nifty. Okay, Tata Steel and Nifty. Calculate the value of Tata Steel return if next year Nifty return is 25%. What is Tata Steel's return if Nifty's return is 25%? Use your calculator, calculate the intercept slope and substitute 25% for X, and you should get your Tata Steel return. Send me your slope value, intercept value, and your Tata Steel value for Nifty return of 25%. What's your slope and intercept? 0.28. The slope is 0.28. Okay. A you're getting as 0.28. So which is your dependent variable? Which is your Y? Dependent Y variable is Tata Steel. Nifty is your X. This is your Y. So we are predicting Tata Steel using Nifty. Did you guys interchange it? Yeah, please correct that. Do you use this correctly? Okay. What was your slope now? 7. Check your data. Like you have to input correctly. This is just most of mistakes or just like data errors. Like when you didn't input the data correctly on the right variable. Because you're not doing any calculation, the calculator is doing it. Okay, Kailash is saying 4.5 and Yeah, that seems. This one is just a data entry. Like you just have to enter the data, then go to linear. Yeah, so I got, I think, 4.58 as intercept and 0.453 for slope. So those were the values when I did last class, I guess. But let's just check that maybe quickly. 8, enter 11, enter down arrow 10, enter 3, enter 18, enter 15, enter 17, 20, and 20, enter 7. So now I think it's in the right order. Second stat, enter down arrow. A is 4.58 and your slope is 0.4532. Right? That's your slope, 0.453, and your intercept is 4.58. So now we can calculate this for 25%. We just have to substitute for x as 25. So instead of x, we will multiply this with 25. So 0.453. So this 4.58 plus this 0.45 into 25. So my A, let me store it in one memory slot, and my slope, let me store it in another memory slot. So what we are going to do, recall 2, which is my slope multiplied by 25 plus my intercept. So 15.91 is the Tata Steel return when Nifty is doing 25%. Okay, now we saw a lot of values in Excel, right? So by next class, you will know everything about that. We should be able to calculate all these values, the sum of square, regression, residuals, mean square. We have some F stat, T stat, P value, R square, multiple R, etc. But now today, I just want, as I said, we will not go into that kind of technical details. We will just look at some basic theory. So we said the dependent variable is the one whose variation is explained by the independent variable. So the dependent variable is what we are going to be predicting. So it is also called as the predicted variable. It is also called as the explained variable, or this is another term, fancy term, endogenous variable, right? So this is the one that we are, endo means inside. This is the one we are trying to predict. The external one is exogenous, which is outside, right? So these are another terms for your dependent variable. We will use the notation Y for your independent variable is explaining the variation. So this is also called as the explanatory variable, or the predicting variable, or exogenous. Okay, if inflation is a factor driving Fed funds rate, Fed funds is the interest rate set by the Federal Reserve in US. If inflation is the factor that is influencing the Federal Reserve to set their rate, Fed's fund rate is an exogenous variable. It's a independent variable. It's a, what is the other one? Endogenous. C is endogenous variable. Which one is Fed's fund rate? A, B, or C? First of all, you can think about this in X and Y. Is this an X variable or Y variable? Y is what is being predicted or explained or dependent or endogenous. So inflation is the factor that is making the central bank set their rate. So inflation is the one that is driving the Fed funds. So for me to know what rate to set, what is the independent variable that is driving that rate is the inflation. Based on inflation, I'm setting the Fed fund. Not based on Fed funds, the inflation doesn't change. Okay. It's mostly based on the inflation, the central bank is going to act and then set the Fed funds rate. If the inflation is high, they're going to increase the rate to reduce the inflation, right? So the inflation is the primary driver of the Fed funds rate. So inflation is going to be your independent variable, and your Fed funds is going to be your dependent variable. Another name for dependent variable is also the predicted variable, the explained variable, or endogenous variable. So in this one, the choice we will go with is endogenous variable. So here we have that initial, let's go back to that Bank Nifty, ICICI. scatter plot we did. So let's say we have more data and we plot these values for ICICI return. Let's say these are these blue dots, right? We have a lot of these blue dots. And now we have to draw this line of best fit. Right? This is the regression line. How do we actually do this line? What is the right line? Why it cannot be this line, or why it cannot be this line? Why is it that I am choosing with a purple line, right? So the question is, how do we get to this regression line? Yeah, but like what if you don't have the observed value for x is equal to 0? You don't know, right? So this is something that could have been a predicted value, right? So in that case, you first need the line equation to get to the intercept. So there are a few ways, but 99% of the time we are going to use, and in CFA we are going to use OLS, that is the ordinary least squared methods. This is the technique we are using for the regression. The ordinary least square is very simple method to get the regression equation. What we are going to do is we are going to look at the observation and try to find a line equation that minimizes the squared distance between the line and the observation. The squared distance, not the absolute distance, not the actual distance, but the square of the distance. The reason why we are squaring is to remove the negative value. If sometimes the data point is a little bit lower and you do that calculation, it might be negative, but when we square it, it will all become positive. So that's the reason why we are squaring it. This is the OLS method, ordinary least square method for regression. This is what we will be doing in level 1. So this is the one that is giving that equation. We are trying to minimize the squared distances between the observation and the regression line equation. So obviously, once you have the equation, the line will intersect with the y-axis, and that is going to give you the intercept, the beta naught, or in your calculator that is given as A. So that is your intercept, and your slope is the change in y for a unit change in x. So this is my delta y and delta x. My beta 1 or slope, which is B in your calculator, is the change in the y variable for a change in the x variable. Now, y bar, which you also get in your calculator, is the average value of y. This is also called as what? The expected value. This is your mean, and your mean is your expected value. We saw that in chapter 3, learning module 3, asset return statistical measures. Your y bar is your expected value. Now, the slope coefficient, if you have not been given the actual observation, but if they are given the variance and the covariance matrix or the variance, the formula to calculate the slope is given as covariance of the two variables divided by the variance of the independent variable. Covariance of x comma y divided by sigma squared x. This is your B in the calculator. Now, covariance of x comma y, how can we write that using correlation? Covariance x comma y would be, if I have to expand it, what's the equation? It's rho x comma y multiplied by sigma x multiplied by sigma y divided by sigma squared x. So you cancel this out, it will become rho xy correlation with the standard deviation of the dependent variable divided by the standard deviation of the independent variable. Oftentimes, we use this to calculate the beta of a stock, that is the slope of the stock with the market, and there it will become the market risk. That is the denominator, and the numerator is going to be the risk of the individual stock. That is your slope of the relationship between the stock and the market, and that is going to be called as beta. Later on, we will see this in many applications in equity and other areas where we are going to calculate. So continuation here. So we have on the two sets of data. We have the number of hours of preparation. So 250 hours, this is all in hours, and your CFA score. And so you can see that seems to be some relationship between this, right? So the more hours you study, hopefully your score will be higher. So do a regression, that is, you have to calculate the slope and intercept and compute your score if you have studied for 600 hours, right? So just a recap of what we did the other class. Let's do this simple computation quickly. Calculate the slope and intercept and calculate your score if you have studied for 600 hours, okay? So this is the question. Please note down those numbers. Just a simple, easy warm-up, just what we had seen in the other class. Let's just do this quickly. So make sure everyone is able to do this. All right, what is your answer? What is the independent variable? What is the dependent variable, first of all? Your score is dependent on the number of hours. It's not the other way. Yeah, so if you are studying for 600 hours, that is your X variable, then what is your, what is your score? What is your predicted score? So I think this is the answer some of you have gotten, right? So you have an intercept of 29.4 and a slope of 0.099. So then you can substitute in your equation, the regression equation, the predicted y. Usually for prediction, we are going to use this hat symbol or caret symbol on top. So that y hat is equal to 29.4, which is your intercept plus. This is the value that they are asking us to substitute in the independent variable multiplied by the slope. And that is giving me a score of 89%. This intercept and slope, you just have to punch it in the data sheet. And that part you got it? Okay. So what they have given is the scores and the hours a student have studied. So they have given this. So what we have to do is just punch in the X variable and the Y variable. So the X variable is the one that is independent and the Y variable is dependent on the X variable. So will you get higher score if you study more hours? Yes. So the score is dependent on the hours of prep. So the X variable is the hours of prep and your score is the dependent variable, which is Y variable. So you have to go to the calculator and type in these values. Should I show this one or do you guys know how to do this? All right, we go to our data sheet first. Always clear the existing data. So X variable we said is the hours prep. The first variable observation is 250. This is my X variable for 250 hours. So you press enter. So as soon as you press enter, it sets that value. The first observation for X is equal to 250. Then you press the down arrow. The Y value is 55. Okay. So if you have studied 250, it looks like you're getting around 55%. Enter down arrow. X0 to 300. Enter. And for that, we are getting 60. Right. Following this one, everyone. 400. Enter down arrow. 71. Enter down arrow. Then you have 500 hours. And for that, the score was 78. And 200 hours, the score was 48. All right, so you entered all the 5 observations they are given for both X and Y. Then you need to compute the slope and intercept. So you go to your stat function. I am already in linear regression mode. If you're not, you have to toggle to until you get to your linear regression. Then it's all set. Already the values would be calculated. You just have to see the value. So press the down arrow and you get all your answers, right? So we only need the A and B values. So your A is your intercept in the calculator, which is 29.45. You understand this? Store it in one memory slot, usually good to store it. Then come down, you see your slope of 0.099, which is given as B in the calculator, store it in another memory slot. So we are now good to go. So if you recall 1, this is my intercept. My recall 2 is my slope. They have asked us what is the score if you are studying for 600 hours, right? If you're studying for 600 hours, what is your score? So 600 multiplied by the X coefficient. 600 is the X value. The X coefficient is the slope. So recall 2, okay? So 600 multiplied by slope, that's giving me 59.89. And then you add your intercept to that. So you get the score of 89.3%. All right. One more practice problem from last class topic. if covariance between income and consumption is 240, the variance of income is 320, compute the slope, and if intercept is 2000, compute consumption if monthly salary is 30,000. Okay, so like in economics, we will see this later on if you have not attended, that there is a relationship between spending and income, right? Usually the more your income is, the more you might spend. It's not, it's just common sense, right? You have more income, you might spend more, you might consume more. So that must be a relationship. So we are finding some data that they have given us the covariance between income and consumption, and that is 240, and the variance of income is 320. Intercept is also given. The question they're asking is, calculate your expense on a monthly or consumption on a monthly basis if your income is 30,000. Okay. First, before you proceed, tell me which is the independent variable, which is the dependent variable. Your spending is dependent on income unless you have a credit card. But here we will assume that you're going to be dependent on your income. And so this one, we are going to use the formula. So they are not given the observations, but you know how to calculate slope using the formula that we wrote last time. Use that, compute the slope. Intercept is already given. Calculate your consumption. What's the formula for slope? Yeah, so the regular formula is covariance between x and y divided by your variance of the x variable. So here you all said x variable is your income and y variable is your consumption. So this will be 240 by 320, I think that is 0.75, right? Okay, so now the consumption is what? When your income is 30,000, your consumption is 2,000, which is the intercept plus 30,000 multiplied by 0.75, 24,500. Okay, so that will be 24,500. So we did similar things. In the first problem, they had given the actual observation. In the second problem, they had given the covariance and variance. So they might give you a covariance matrix, and from that, you will have to calculate the regression coefficients. Okay, that's a little bit of theory that we need to know, very important actually. So what are some of the basic assumptions for you to do linear regression? Linear regression is possible only certain conditions are met. Some of these are very obvious, like there must be a relationship, linear relationship between the dependent and independent variable. That's fairly obvious, like how we have seen, your study hours, number of hours, and your CFA score, your income and your spending. So that would be a relationship. It makes sense to do a linear regression in these cases. Next one is a little technical one. The variance of the residual term is constant for all observations. It's called as homoscedasticity. The variance of the residual is another name for the error term or the noise term. So you are predicting some value. Let's say you are predicting 89% if you study 600 hours. So let's say all of you study 600 and your score is 91%. So that is a 2% error from our prediction. That is your residual term. Now the variance, that is the deviation, squared deviation, should be constant for all observations. Whether I do it for 600 hours or 700 hours or 650 hours, that variance term should be constant. If it is not, then we call what is called as heteroscedasticity. That is an issue with linear regression. If you're doing statistical analysis, you check for heteroscedasticity. Those tests are not there in level 1. In level 2, we are going to see some tests for multicollinearity, heteroscedasticity, all of those. So what is this? Maybe a little bit, maybe visually, if you think about it. See, the blue line is my linear regression line. That's what is predicting the value of y for a value of x, right? Now, the actual observation, if it is like the dark blue or the red one, there is no problem, okay? So the predictions are like this. Whether x is very small value or if it's a large value, the distance between the observation and our prediction is not very different, okay? But you look at the light blue dots, right? As my x value increases, the variance or the distance between the line and the observation is also increasing, is changing, right? So it is not constant. the variance or the deviation between the observation and the predicted value from the linear regression equation is different. So this is called as heteroscedasticity, and that is not something we can allow if you are doing linear regression, because then the prediction is not going to be accurate. Okay? So that's the concept that we are seeing in the second point. So the first point, the linear relationship, obviously, like there could be a relationship like this, but this is not linear. So we can't use a linear regression equation. The last 2 points are fairly obvious. The residual term, that is the error terms, are independent and they are normally distributed. So this should be the case, because the error terms, that is this variation between what we actually see and the predicted value, that difference, that error terms, they are not dependent on anything. They're not dependent on the X variable itself. Okay, so they are independent and they are normally distributed. So this is also called as IID variables, independent and identically distributed variables. So the residuals have to be independent. Test of independence is something we will do for residuals later on. Okay. So these 4 conditions have to be satisfied for us to perform a linear regression. And we are only doing in level 1 single variable, right? So we are not using multivariate linear regression, only single variables. So our life is a lot easy in level 1. So much fun. Only just need to know few things, right, in level 1. All right, so we'll move on and look at another concept now. Everyone clear with the assumptions? All right. So now we are going to do the ANOVA. ANOVA stands for analysis of variance. Last class, we did this in Excel and the ANOVA table was generated, right? So do you all remember this one? Like you can go home and try it, like definitely practice some regression. You can just pick some stock and pick a benchmark and see the regression equation, how it is, right? I think we did this. Okay, so this was the output, regression output. And you can see there was some basic stat here, R square. We will see some of this computation. We need to actually be able to do all of this computations in level 1. Till this part, at least we have to. So some T-stat as well we are doing. Basically, all of this we need to know how to do in level 1 for a single variable linear regression. This is your analysis of variance. So let's look at the first one. Let's see if there is a table. Yeah. So you can see the residual part. The residual part is the variation between the prediction and the actual observation. You can see it's not, except for one outlier, everything seems to be very close, right? It's a relatively good prediction. And that prediction, how good of a prediction is given by this R squared. We will see what is that in a second. The higher the number, the better the prediction. Okay, now let's go one by one. To look at this one, maybe we will have to go back to the whiteboard. Okay, let's say this is Nifty and some stock. Nifty is the independent variable, so it's on the x-axis, and the stock returns, I think it is TS, Tata Steel, I guess. Okay, so this is your Y variable. So you're going to predict Tata Steel returns using Nifty returns. Right? Simple linear regression. So what you will start with is you will start with some observations of Tata Steel returns and Nifty returns, and you will calculate the X bar and Y bar. Y bar is the average of Tata Steel returns, and Y bar is the, Y bar is the average of Tata Steel returns, and X bar is the average of Nifty returns. Let's say my Y bar, that is the average returns for Tata Steel, is 11%. Okay, let's assume this is the case. My Y bar is 11%. But then we will have some equation, right? So we are going to have a regression equation, some with some intercept and slope, and that is what this Tata Steel equation is, right? Regression equation. So based on Nifty's performance, Tata Steel's performance, we are going to predict. Now, let's say for 10% returns on the market, our prediction is 14% for Tata Steel. Okay, so this is our predicted value, and how do we notate the predicted value? We said with that hat symbol, right? Remember this? So the Y bar means the average return, and the hat means what we have predicted. So this is the notation, what the curriculum is also using. You will use the same one. And the actual observation will be with the subscript yi, right? For that observation, ith observation, like second, third, fourth, whatever. And the actual observation might be slightly different than our prediction, right? That is why we have a error term. And let's say this is my actual observation for Tata Steel when Nifty earned 10% annual return. Okay. So we are expecting 14%, but let's say Tata Steel that year gave us 16% return. What is your residual? So the residual is the difference between the prediction and the actual observation, and that is 2%. If you didn't do regression, what is the total error? Like, let's say you didn't do regression. You just looked at Tata Steel's returns and you are seeing, okay, it's giving us 11%. It is giving us 11%, but this year it gave us 16%. What is the total variation? 5%, right? Your expected return would be 11%, right? Based on the average. And the total variation actually happened to be 5%. It came out at 16%. Now, out of that 5%, we were smart enough to figure out the 3% of the variation using regression, right? We said, okay, if Nifty is 10%, then it should be 14%. But there was a 2% that we missed out, right? So the total variation, we can divide it into explained variation and unexplained variation. The explained is the one that we are able to explain using regression. And the unexplained is something we are unable. This is a error term. So in our case, the explained is y hat minus y bar, and the unexplained will be the yi minus y hat, which is 2%. The SST, right? So this is what's there in our ANOVA as well. The sum of square total, that is summation of the total variation, square of the total variation for all observations. That is your SST, sum of squares of total variation. In your Excel, they will just say SS, and then you look at total, sum of square. SS stands for sum of squares, and T stands for total, right? Which is your summation I is equal to 1 to n, the square of the total variation. Then you have SSR, which is this one, sum of square regression, right? In our ICICI example, this was 187. Okay, the sum of square regression is the square of the predicted value minus the expected value, that is your average. So that is your regression sum of square, SSR. Then you have the last one, which is the sum of square of error terms, which is the observation minus the predicted squares. The difference between those and the square of those terms. Are we following this? Same thing what we talked about here. Instead of having it as just like a difference, we are squaring it. That's all. If you square these two, you sum them up and then you add, you get the total sum of squares, right? So that is what we have done. The reason why we are squaring is because we don't want negative values. That's the reason we always square mostly in our stat, right? So that the difference, whether it is negative or positive, it is showing up as a positive number. It doesn't matter to us for calculating the error terms. Okay, so the total variation sum of square is equal to SSR plus SSC, basic equation, which we already have seen. This is the sum of squared regression plus sum of squared error terms is equal to your total variation sum of squared total. Okay, now let's go to the Excel and let's just double check this one. So how do we do this sum of squared total? How can we calculate this for Bank Nifty ICICI regression equation? What do we first need to do this? We need the average, right? Like that is the difference between the predicted value and the average. We have to square it and add it. So let's first find the average for ICICI. So 10.8% is the average return. So my predicted return is going to be what? We said it is this intercept. Let's lock that. Plus my slope. Let's lock that. Multiplied by the X variable, Bank Nifty, right? So 8.62 is my prediction. This is my actual is 7%, and my predicted value is 8.62, and my mean is 10.8 that we just calculated. So far we have all the values we need for the first observation. So let's do this one. SSR, SSE, SST. So what is the SSR? Equal to the difference between regression, sum of square regression is what? The difference between the prediction and the mean, correct? Okay. So we will do that, 8.62 minus this one. And then we have to take a square. Obviously, this is sum of square. So that is that value, 4.754. Okay, now my SSC is what? Sum of squared errors. This is your prediction minus the actual, which is this minus my predicted value. Following this? And then we have to take a square of this. And my SST is the total variation, which is going to be the observation minus the mean, correct? Square. So let's do this for every other observation. I'm just going to drag it. So the mean is always 10.8. That's fine. So now let's just do this one. Okay, now let's just format this a little better. Okay, so there we have it. And now we will do the summation. So 187, so that is slightly different from what they have done. I think it's some kind of rounding that we are doing. So 187 is the sum of square regression. Like you can see that sum of square regression is summation of the observation, the difference between the observation and the predicted value, right? So that is your sum of square regression is what? This is your mean and the difference between the mean and your predicted value square. That is your sum of square. Your sum of square error is the difference between the predicted and the observation, and sum of square total is the total variation. And you can see that the values are 200.8 for total. Your SSC is going to be 13.56 and your SSR is 187. You can see that it is exactly the same. This is how you will calculate your SSR, SSC, and SST. Most likely in exam, they will not ask you to calculate it this way. It will take you a lot of time. We don't have Excel or Python in exam. So mostly they will probably just give you that and they will ask you some other question. But you need to understand how this is calculated. Now coming to this DF, DF is what? Degrees of freedom, right? So for the regression, for a univariate, it depends on the number of variable. For a univariate, there's only one variable. So the degrees of freedom is 1. So we call this the independent variable. We usually notate it as K. For univariate regression, my K is 1. So my degrees of freedom is 1. And for the residual, the degrees of freedom is N minus K minus 1. This is for the degrees of freedom. K is the number of independent variables. Okay, I'm just going to write it so that you can note it as well. Number of independent variables. And the degrees of freedom for residual is N minus K minus 1, where N is the number of observations. What is the number of observations we have? 5 we have. We have 5. 5 minus K, 1, minus 1. So it is 3. Yeah. So 5 minus K minus 1. Given that in CFA level 1, it is always one variable, you can simplify this formula to N minus 2. The degrees of freedom for the error term or the residuals. See, here they are calling it as residual. In CFA level 1, we are calling it as error. Okay, it's the same thing. N minus 2 is your degrees of freedom. The total degrees of freedom is a summation of the degrees of freedom of regression and residuals. Any questions still so far? Are we all on the same page? Are we all following this one? Now, the next one is your mean sum of squares. So the mean square is your sum of square divided by the degrees of freedom. Okay. So your MSR is equal to what? Your SSR divided by degrees of freedom, which is K. Again, given that it is just 1 in for CFA level 1, MSR is equal to SSR, but the general formula is SSR by K, the mean sum of square regression, right? And the MSE, so in CFA, they are calling it as MSE. In other textbooks, they call it as residuals. Okay. MSC, this one is going to be your SSC, sum of square error. We are calling this in CFA as error term. SSC divided by the degrees of freedom. Okay. So that's what is happening here. So basically what this is your 13.5 divided by your degrees of freedom, which is 4.51983. Okay, so far everyone understanding how to calculate SSR, SSC, SST, MSR, and MSC. Right? So this is the basics you need to know to calculate the analysis of variance, the ANOVA table. Now let's see how we can use this and come to a conclusion about our regression. Right? So that's the whole purpose of doing this analysis of variance, is to see if this regression is actually what, like, are we able to actually predict ICICI return? See, if you think about the goodness of fit, whether this regression is good, is it a good fit, right? One way to see is, what is the total variation out of which how much am I explaining? What is the total variation out of which how much is the regression explaining? Okay, so that is given as R squared. R squared is your explained variation divided by your total variation. Explained variation divided by your total variation, and explained variation is your SSR in our case. Right? This is what is being explained, and the total variation is 200.8, which is 93%. 93% of the total variation we are explaining using the regression, which is pretty good number, very high number. So the higher the R square, obviously if it is 100%, that is usually not possible unless you're doing with the same variable. But anything in the 90s is obviously a very good fit. So Nifty, Bank Nifty is a good variable to use to predict ICICI. That's what we are seeing is R square. And once you have this R square, usually what you can do, you can take a square root to get to the multiple R. Okay, multiple R, you can do a square root and get to that. This is the number before this, right? But because we are using a single variable, it is also the same as the correlation between the two variables. That is your correl function, my array 1, Bank Nifty, x-axis, and my array 2, ICICI. And that is also going to give you the same answer. The multiple R is a square root of R squared, but only as a special case for univariate linear regression, you can also find it as the correlation. If they give you the correlation, you can also calculate R squared, because then you can just square that and get to R squared. Okay. Now, I just showed this for you to understand. We will look at this in whiteboard. We will write the formulas and solve some problems. Okay. Do you all understand how to recreate this? If Excel suddenly doesn't work, can you do this by yourself manually? You should be able to do it, okay? But you don't have to do it. Just for you to understand the calculations. All right, let's go back and write down these formulas properly. So my degrees of freedom, I'm going to assume one variable because we are in CFA level 1. They are not going to ask us multivariate. So this would be the degrees of freedom. And my MSR is going to be equal to SSR. And my MSC is equal to SSC by n minus 2. Because my K is equal to 1. But generally, this is going to be your K. And this is going to be n minus K minus 1 as the degrees of freedom. But K is equal to 1 for us. Square root of MSE is also called as the standard error of estimate. So when we do hypothesis test, we need our standard error, right? So this is given as square root of the mean square error term. You take, so this MSE, you got it by dividing the sum of square by n minus k minus 1. You take a square root of that, you get the standard error of the estimate. So this is another formula. So using SCE, standard error of the estimate, you can also figure out the goodness of fit. The lower the error, obviously, the better the model fit, because MSE is based on the error terms, sum of square error terms divided by n minus k minus 1. So you take a square root. So this is going to give us the error issue. So the lower the error, the better the fit. The other one, R square, which was what is actually given in the Excel, right? That's what we saw for the goodness of fit, is SSR by SST. That is the better way to remember this is explained variation divided by total variation. For simple linear regression with one variable, R square is equal to the lower R or rho square, the correlation coefficient, which is why our multiple R can be a square root of R squared, which is also equal to the correlation coefficient. Okay, now we'll do a sample problem. What is your R squared and SCE for this ANOVA table? They are given the degrees of freedom. They are given sum of square residuals. We call this, this is your error term. This is your regression. There is a bit of a difference between FRM and CFA in terms of notation. So here, CFA, we use regression for the explanation. And for the residuals, we are calling it error. And this is total. Okay. Compute your R squared and SEE. How do you calculate your R squared? What's the formula? Very nice. SSR by SST. What is that? You're getting 18.5%. See if you're getting the same answer. Then after that, calculate your SEE. SEE is your square root of MSE. And MSE is 0.001373. You just take a square root of that and you'll get 3.7 as I heard here. Very nice. Shall we move on? Everyone noted it down? Okay, next question. SCE is 0.0127. Number of observation is 30. SSR is also given. Compute R squared. So this one, I'm not going to give you the solution. Like you first calculate it. So you have to do, I think, 2 steps to get to R squared because they have not given SST. You have to calculate SST. For that, you need to do 1 step using SEE. Okay. And then you can use your R squared. R squared formula is your SSR by SST, but they have not given SST. So you have to first compute SST, then compute your R squared. So what was your first, like your SST? To calculate R squared, you needed SST, right? So how did you get your SST? You first needed your SSE, right? So from your SEE, you can get to your MSE, and then you can calculate your SS, right? So SEE is given. So my MSE will be square of the SEE, which is 0.01629, and SSE is equal to MSE multiplied by n minus 2. N is 30. So n minus 2 is 28. So this number multiplied by 28 is giving me my SSE of 0.0045. So then once you have this SSE, you can add it to the SSR to get the SST and substitute in the R squared formula. That is the same thing. We are also doing the same thing only. So SSR by SST is the formula for R squared. That is what you guys also did, no? SSR by SST. That is what we are also doing. SSR plus SSE you add, you get 0.00646, and your SSR is 0.00213, and you would have gotten it as 32%, 0.32. What's that? 0.32 only, no? So what is your SST? Is this 0.00646? No. So your SSR they have given already, right? So SSR is 0.0213. What is your SSE? Yeah, no, it's not directly given. We have given SCE, you have to calculate MSC, and from MSC, you have to calculate SSC. Yeah, it's not directly given. This is not SSE, okay? This is SCE, standard error of the estimate. So from SCE, you can calculate MSC. From MSC, you can calculate SSC. There's a question online. Yeah, okay, we will look at this solution one more time. See, it's not a difficult one. Let's just do this one more time though. Maybe if we do it together, it will be easier to follow. So let's see what's the values. SCE is given as 0.0127 and the N is 30. SSR is given as 0.00213. We know that SCE is equal to square root of MSC. So my MSC will be SCE square, which is 0.0127 square, which is 0.00016,129. Highly recommend that you store this number in a memory slot, and that is 0.32. SSC I'm getting as so 0.0045 is your SSC. You add this, and you're getting 0.0064 or something. I didn't do that calculation. I just typed in whatever you said. This SSC plus SSR is this correct? 0.006. Is this now clear? Okay, so that finishes most of the regression part.